In the last video, I showed you the definition of the Laplace as well as a very simple example of the Laplace of 1. Here I'm going to do the Laplace of a larger function here. So we'll do the Laplace of e to the at. And we're going to do this the same way as before. We're not going to use any of the cheat sheet rules. So if we recall, our formula is equal to the Laplace of f of t is equal to the integral from 0 to infinity of e to the negative st times f of t dt. Okay, so now we need to plug this into this section over here, and we will get okay, so now we have plugged this into here, and here's our new formula we come up with. Alright, so now we need to do something to combine these. So we'll factor out the t's. This actually can factor down into something that looks like e to the negative st plus a t dt, and that's just a rule using the exponential function. When two e's are multiplied together, you can take whatever's up on top here and add them together. So now that we have this, we need to factor out the t's. That is going to equal e to the negative t times s minus a dt. Alright, and now we need to just go ahead and take the integral of all of this. That is going to be 1 over minus s minus a here. I'll just go and put that back up on top. E to the negative t s minus a, and we're going to do that from 0 to infinity here. So here is our new formula. Alright, and now we'll just bring this down and solve all this. So we have negative 1 over s minus a, e to the negative infinity s minus a, and we'll take that and we'll subtract 1 over s minus a e to the 0, and that's going to be e to the 0 s minus a, but since it's e to the 0 and this is going to be multiplied together, that's not going to matter. So this right here is going to be equal to 1, and once again, from like the last one, we can make these into positives because it's a minus a negative number here. So the right side of the formula is going to come down to be 1 over s minus a times e to the 0, and this is going to be equal to 1. So this is the right side of our formula, plus, and then on the left side over here, this is going to be negative 1 over s minus a e to the negative infinity times something. This is going to all equal 0. So when we do the negative 1 over s minus a times 0, this whole side over here is going to cancel out. So we get 0 plus 1 over s minus a is equal to 1 over s minus a. And that is our Laplace transform of e to the at. Now we can take this and build upon it. If we plug in a number such as 2 into here, so you have the Laplace of e to the 2t, this a right here becomes 2, and down here in our formula of 1 over s minus a becomes 1 over s minus 2. Anything we plug in for a will end up as this term right here. Alright.